This is an equation with matrices, and we're supposed to solve for x and y. X and y are just regular variables. They're not matrix variables, and they are found as entries within the matrices. So here I have one matrix plus another matrix equals this matrix. So I need to add these two matrices together. Remember, adding matrices is very easy. Just add them position by position. So I'll add the 2x and the 3, the 9 and the 0, the y and the -7, the 2 and the -4. So when I add these two matrices together, 2x plus 3 is 2x plus 3, 9 plus 0 is 9, y plus -7 is y minus 7, 2 plus -4 is -2, and that has to equal 13, 9, -3, -2. So now that I know that these two matrices are equal, I know that each part of the matrix has to be equal. So 2x plus 3 has to equal 13. 9 has to equal 9, which is good because it does. So that doesn't really help us, but it lets us know that we're doing things right. Y minus 7 has to equal -3, and -2 has to equal -2. So to find x and y, I'll start by taking this entry, 2x plus 3, and setting it equal to 13, or 2x equals 10, or x equals 5. To find y, I'll take this entry, y minus 7 equals -3, or y equals 4, and so there's my answer. X equals 5, and y equals 4. Okay, so let's take a look at another one. Here's another equation with matrices in it. We've got an x we need to find, we've got a y we need to find, but here we have matrix multiplication instead of matrix addition. So the first thing to do is to check, make sure, can we really multiply these matrices? And if we can, do we end up with a matrix that's this correct size? So this matrix has 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. So this is a 3 by 3 matrix. This matrix has 3 rows, 1, 2, 3, and 1 column, so it's a 3 by 1 matrix. Since these two numbers are the same, we can multiply these two matrices together, and our answer should be a matrix that has dimensions 3 by 1. Is that what we have over here? And the answer is yes. We have 1, 2, 3 rows and 1 column, so this is a 3 by 1 matrix. So if we multiply these two matrices together, we can set it equal to this one. Now remember, when you multiply matrices, you multiply a row times a column. So I'll start by saying I'll take my first row here, first row, row 1, and column 1 over here, row 1, column 1, and then I'll multiply together the individual parts. I'll multiply -2 times 1 plus 1 times x plus 2 times 3. That's what I mean when I say multiply a row by a column. You multiply each entry together with its corresponding number in the other matrix, and then you add them all together. So row 1 times column 1 is -2 times 1 plus 1 times x plus 2 times 3. And that equals -2. Okay, plus x plus 6 equals 4 plus x. Okay, so that was row 1, column 1. Now I'll do row 2, column 1. So row 2, column 1. That will equal 3 times 1 plus 2 times x plus 4 times 3 equals 3 plus 2x plus 12 equals 15 plus 2x. Okay, now we'll do row 3 times column 1. So row 3, column 1 will equal 0 times 1 plus -2 times x plus 4 times 3 equals 0 minus 2x plus 12, or 12 minus 2x. Okay, and that's all I can do. I've multiplied every row that I have here times every column I have here. If I had another column here, I'd have to go back and multiply row 1 times column 2 and row 2 times column 2, but I don't. I'm all done. And so my answer here, after multiplying these two matrices together, in row 1, column 1, I have 4 plus x. In row 2, column 1, so this is row 1, this is row 2. Row 2, column 1, I have 15 plus 2x. And in row 3, column 1, here's row 3, column 1, I have 12 minus 2x. And I did in fact get a 3 by 1 matrix, which I was expecting. So now I know that 4 plus x, 15 plus 2x, 12 minus 2x has to equal 6, 19, y. So just position by position, I can set them equal to each other. So 4 plus x has to equal 6, or x equals 2. So now I know what x equals. Now I could set 15 plus 2x equal to 19, but all I would do is get x equals 2 again, so that won't help me. So now I'll set these last two equal to each other. 12 minus 2x equals y. I need to find out what y is. I have an x in here, but that's okay because I know what x is. I can substitute back in. So this gives me 12 minus 2 times 2 equals y, or 12 minus 4 equals y, or 8 equals y. So there's my answer. X equals 2, y equals 8. This one's a little bit different. In this one, our variable is actually a matrix. So when we finish with this problem, we should have an answer that is a matrix. It's solved for matrix X. So this X here is going to be a 2 by 2 matrix. So this is an equation of the form something times x minus something equals something else. If I had 5x minus 3 equals 2, you know your first step would be to add 3 to both sides. And it's the same thing here. I want to isolate the x. I want to get the x by itself. So I'm going to add this matrix to both sides. Okay, so then these cancel each other out, and I'm left with, now I add these two matrices together, and when you add matrices together, you just add them position by position. -1 plus -2 is -3. -3 plus -1 is -4. 6 plus 0 is 6, and -4 plus 2 is -2. Now I need to get x by itself. If this was 5x equaled 10, we know we divide both sides by 5. You do the same thing with matrices, but you can't divide by a matrix, but you can multiply by a matrix's inverse. So what I need to do is multiply both sides by the inverse of this matrix. So I need to find the inverse of this matrix and multiply both sides by it. And I have to be a little careful because matrix multiplication is not commutative. The order does matter. So let's take a look at what we have here. I multiplied this inverse matrix times this matrix so that they would cancel out. And so I put this inverse matrix in front. So that means I needed to put the inverse matrix in front over here too. Now when I multiply these, they'll cancel out and I'll be left with x equals, and now I need to multiply the inverse of this matrix times this matrix. Well, that takes a little bit of work because I have to find out what the inverse of this matrix is. So I'll do that calculation over here off on the side. So to find the inverse of a matrix, what you need to remember, if you have a 2 by 2 matrix, let's say our matrix is A, B, C, D, then the inverse of that matrix, A, B, C, D, equals 1 over AD minus BC times the matrix where you swap the positions of A and D, so it becomes DA, DA, and you change the signs of B and C, so this becomes -B and negative c. So we want to find the inverse of this matrix right here. So to find the inverse of this matrix, we're going to take so 1, negative 2, 3, 4, inverse. So it'll be 1 over 1 times 4 minus 3 times negative 2, so minus a negative 6, times the matrix where I swap the positions of those two, so it's 4, 1, and I change the signs of these two, so it becomes negative 3 and 2. So then this becomes 1/10 times 4, negative 3, 2, 1, or now when I multiply a matrix by a number like this, I multiply each thing in the matrix by that number. So I get 4/10 is 2/5, negative 3/10, 1/10 times 2 is 1/5, and 1/10. So that's what I get as the inverse matrix. So this value right here equals 2/5, negative 3/10, 1/5, and 1/10. Now I'm going to pause here for just a second because I want to double check my work on that, because that's, you know, a lot of multiplication and fractions and stuff. So let's just make sure I did it right. So I'm going to use the calculator to check myself. So I'm going to put my matrix here. I'll put it in matrix A, it doesn't matter. So I'm going to edit matrix A, and my matrix is a 2 by 2 matrix. And the matrix I wanted to find the inverse of was 1, 3, negative 2, 4. So let's see. One, 3, negative 2, and 4. Now I just want to see, did I calculate the matrix correctly? So I'll go to matrix, I put that in matrix A. I want to see what its inverse is. This button right here will find the inverse. So the inverse of matrix A is, did I do it twice? Is that what happened? Yeah. So 4/10, negative 3/10, 2/10, and 1/10, and that is what I got. So I did do it okay. So that's fine. Now I need to multiply that inverse matrix times this matrix. And I remember that when I multiply matrices, I multiply rows times columns. My answer, this is a 2 by 2 matrix times a 2 by 2 matrix, so 2 by 2, 2 by 2. These are the same, so I can multiply them. And my answer should be a 2 by 2 matrix. So, let's see. If I multiply row 1 times column 1, so this row times this column, I get 2/5 times negative 3 is negative 6/5 plus negative 3/10 times negative 4 is negative 12/10, which is 6/5, which is 0. Now I'll do row 2, column 1. 1/5 times negative 3 is negative 3/5. So I'm doing row 2 times column 1. 1/5 times negative 3 was negative 3/5. 1/10 times negative 4 is negative 4/10, or negative 2/10, so plus, or negative 2/5. So 1/10 times negative 4, negative 2/5, or negative 1. Now I'll do row 1 times column 2. Row 1 times column 2. 2/5 see, this is a 6, right? Yeah. So row 1 times column 2, 2/5 times 6 is 12/5 plus negative 3/10 times 2 is 6/10 or 3/5, which is 15/5 or 3. Okay, now my last one that I need to do is row 2, column 2. So row 2, column 2, 1/5 times 6 is 6/5. 1/10 times negative 2 is negative 2/10 or negative 1/5, so plus negative 1/5, which is 1. And so my final answer should have, in row 1, column 1, row 1, column 1, I have 0. In row 2, column 1, I have negative 1. In row 1, column 2, I have 3. And in row 2, column 2, I have 1. And that should be my answer. Now I'm just going to double check this on my calculator. I already put in that A was the matrix. Let's go back and look here. I put in that A was this matrix. So now I'm going to put in this matrix as matrix B. In the calculation I'm going to have the calculator do is this one. I'm going to tell it to multiply the inverse of A times B, and we'll see if we get the same answer. So I already have 1, 3, negative 2, 4 in A. Now let's put the other one in B. So second matrix, go over to edit. I'm going to edit matrix B. Matrix B is a 2 by 2 matrix, and it should have the values negative 3, 6, negative 4, negative 2. Go back to my home screen, second quit, and I'm going to take matrix A inverse because I wanted matrix A inverse times matrix B, and I get 0, 3, negative 1, 1, which luckily is in fact what I got.